So let's say evaluate 0 to 1 dx upon 1 plus x or dx upon 1 by 1 plus x by dividing into 6 equal intervals by Simpson 3/8 rule. Simpson's 3/8 rule. Now here we have provided n is equal to 6, number of intervals 6, and h is equal to b minus a upon n, that is equal to 1 minus 0 divided by 6, that is equal to 1 by 6. Now it is the new problem in this section that if we divide 1 by 6, it is non-terminating fraction. If we will round off, it will affect the result. Then what we do, we keep the value in its pristine nature. That is, say x is equal to, we start with say 0, we have to go from 0 to 1. Next value 1 by 6. After that 2 by 6, 3 by 6, 4 by 6, 5 by 6, and interval 1, 2, 3, 4, 5, and it is 6 by 6, that is equal to 1. Now we can check the intervals 1, 2, 3, 4, 5, 6, and we count it as 1. For this, we find the value of the y for the given function, that is also the fair word. X is equal to 0, then y is equal to 1 upon 1 plus 0 is equal to 1. When x is equal to 1 by 6, then y is equal to 1 upon 1 plus 1 by 6, that is equal to 6 by 7. That is equal to 6 by 7, that is 6 divided by 7, it is 0.8571. 0.8571. Then 2 by 6, it is y is equal to 1 upon 1 plus 2 by 6. It is 6 by 8, that is equal to 3 by 4. It is 0.75. Then y is equal to 1 upon 1 plus 3 by 6, that is equal to 6 upon 9. 3 to the 6, 3 to the, that is 2 by 3. It is 0.6667. Next, 1 upon 1 plus 4 by 6, that is equal to 6 by 10, and that is equal to 0.6. Then for 5 by 6, 1 upon 1 plus 5 by 6 is equal to 6 upon 11. 6 upon 11. 6 divided by 11, that is equal to 0.54. And for 1, it is 0.5. Thus simply we can calculate either the function is algebraical, trigonometrical, whichever it may be, and we are concerned with only mean, height, or the number of the intervals to decide the formula. Here we are going to use Simpson's 3/8 rule. For that we see Simpson's 3/8 rule, that is, here we mark F0, last value F1, F2, F3, F4 and F5. Now it is clear. We shall use the composite 3/8 rule. That is h by 3h by 8, I is equal to 3 by h by 8 into F0, first bracket F0 plus F1. We select first and last. And the remainings, that is 3 times of plus 3 times of F1 plus F2 plus F4 plus F5. F1, F2, F4, F5 plus 2 times of F3. That is equal to 3h by 8. H is 1 by 6. 3 into 1 by 8 into 6. That is equal to F01 plus 0.5 plus 3 times F1 0.8571 plus 0.75 plus 0.6 plus 0.5454 plus 2 times of F3. Here F3 is 0.667. 0.6667. Now we can calculate it. That is equal to 3 by 48 into 1.5 plus it is 0.8571 plus 0.75 plus 0.6 plus 0.5454 into 3, that's equal to 8.2575 plus 0.6667 into 2, that's equal to 1.3334, and the final result is 1.5 plus 8.2575 plus 1.3334 into 1.5 plus 8.2575 plus 1.3334, so this into 3 divided by 48, and this will come to be 0.6932. That is the Simpson's 3/8 rule. What do we see in all the methods? Here the formation of the table, this table here, up to this, it is a common in every method. It only depends upon the value of the n or h. We will be provided with either n or h. N for interval, h for height. Then we calculate the table for the given function and we decide which formula is to be used or what is the requirement of the problem during the exam. There is, again I repeat, no difference, only these formulas are separated to make the calculations easier for simple formula and composite formula, and the formula, we studied 3 formulas, their approach is same, their objective is same, only the difference is some formula provide the more exact values than the other. Now we see the different type of the formulas in the numerical integration, that is the Gaussian quadrature, and it is the typical form of the numerical integration. It is from the Gaussian quadrature. It is totally different from the formulas which we studied just before it. The Gaussian quadrature, we use the formula for let us see, that is the standard formula. We call it number 1, 2-point formula. 2-point formula. Or we say for n is equal to 2. We use the formula -1 to 1 f of x dx is equal to f of -1 by root 3 plus f of 1 by root 3. It is the standard result, and these limits are standard limits provided with the function. It is the Gaussian quadrature with the 2-point formula. Now let us do compute problem on this. Say compute the integration 5x cube minus 3x square plus 2x plus 1 with respect to x from -1 to 1 by Gaussian quadrature using 2-point formula. That is simple one. Nothing to do. We have to change the x with these values. It is only when these values are -1 to 1, they are in the standard form. If they are not in the standard form, then we will have to convert them into the standard form. That we will see into the next problem. Here we write the solution, that is 5 into, first of all we write first value 5 into -1 by root 3 cube minus 3 into -1 by root 3 square plus 2 into -1 by root 3 plus 1. Then further plus this one, 5 into 1 by root 3 cube minus 3 into 1 by root 3 square plus 2 times 1 by root 3 plus 1. We can simplify it with a simple arithmetic. 5 into -1 by 3 root 3 minus 3 by 3 minus 2 by root 3 plus 1 plus 5 into 1 upon 3 root 3 minus 3 upon 3 plus 2 by root 3 plus 1. That cancel the same values here. 3 by 3, 3 by 3, 2 by root 3, 2 by root 3, and we get the answer is 2. That is the simple form of the Gaussian quadrature. Now we see the next problem. We shall discuss about a Gaussian quadrature in which these limits are not in the standard form. Then what should we do? We first of all change the values into the standard form, and we will discuss it later on. Up to this, any problem, any query or any question regarding this topic? It is a numeral integration. It is a typical form of the integration. The calculations requires a lot of patience and the concentration and the practice on the system which you use usually during the exam. Don't think if you carry the new calculator in the exam, you can carry the calculations exactly. It will create the problem. Okay, thank you and good day.